about this building, imagine if we make a measurement in this side and in this point, we are going to find that the properties of the soil are are different between the 2 points, but also are different with depth. So the properties of the soil vary with depth and also with horizontal scale. But what happened with this? This is a big problem in geotechnical engineering because this variability of the soil brings a lot of uncertainty in the design. And for years, geotechnical engineers have been developed the design in a deterministic way. In the deterministic design, we assume that the soil is homogeneous. It's not heterogeneous, it's homogeneous. And we also only need measure one property or 2 properties. And with this measure, for instance, we have a friction angle of the grave. And with this property, we designed this building. And this is why it's not good because, as I say, it brings a lot of uncertainty in the design. But in recent years have been developed another way to design the probabilistic designs. And in the probabilistic designs, it includes the variability of the properties in a random way. This is a representation of this mountain. We see the different scale of the colors. It means that there is a different measure of the value of the property of the soil. And the probabilistic designs take into consideration the variability of the soil properties, and in order to make a safety and in order to reduce the risk of the design. So, deterministic design no include the soil variability. This is high uncertainty in the design. And the probabilistic design, it includes the soil variability and also includes the variability of the loads. That this method don't include, but this is another thing. And this is reduce the uncertainty in the design. But in order to calibrate this probabilistic design, these numerical designs, we need to make measures in situ, in the soil. But this is very costly. So there is another tool to calibrate these numerical models, and this is making physical modeling. But making physical modeling, we need to represent or recreate the soil variability in lab. This is not easy, and this is the idea of this paper. This is the objective of this paper is to represent a new technique to prepare soil with control variability. It includes the construction and test of artificial fabricated specimens in the centrifuge, geotechnical centrifuge. So the procedures that I follow is this. First, I generate the soil spatial variability using a random field modeling technique. Second, I started to construct the specimens of the modeling using 9 mixes of different percentages of kaolin and bentonite. Kaolin and bentonite is a type of clay. And then, when we finish to construct this, I subject these specimens to consolidation. And after that, I finish. I evaluate the soil resistance of the specimens and compare with in situ tests in order to be sure I'm recreating in a good way the variability of the soil. This is the steps 1, 1, 1, 1, 1. First, in a numerical way, I recreate the variability of the one property. This is each of these square represents a different measure of the liquid that is a soil property. I use a technique the result. This is the physical model that represents this random field. To create the physical model, I use this kind of caulking guns and a container. And this is each of these. This is the soil, homogeneous soils, and each of these have a different Lucke limit. When I finish doing this, I subject this specimen to consolidation in two steps. One, volumetric path, and the other is using the centrifuge, the geothermal centrifuge. This is the consolidometer, the Amato consolidometer. This is where the specimen have 30 kilopascals of pressure. I put them into the geotechnical centrifuge and centrifuge during 4 hours in 2000 gravities. This is the mini geotechnical centrifuge, and this is an MLA 138. When it's finished, I measure the resistance of the soil with using a mini cone penetrometer. This is the mini cone. This is the results of the cone resistance. This is not so variable, but I'm improving this technique in order to make it quite variable and equal to the in situ test. That's it. Thanks.
Quick questions? No?